Hey guys, it's Mr. Mulvihill here with our notes for the day. This is a vocabulary cheat sheet in algebra that a lot of these words are popping up and already have popped up, and it's important that we have a clear understanding of the difference between each of these terms. So a variable, a definition for it is a letter which represents an unknown quantity. And you guys are writing this down. A letter which represents an unknown quantity. If you guys remember, we did dog years and track labs and how high a tree grows and pounds and all of this stuff. And all these letters represented some quantity. They stood for something usually, like T for track labs or D for dog years. Most often in algebra, we might see X. So all three of these are examples. It can be any letter. An expression is a statement with letters and, we'll be more specific, with variables and numbers. It's a mathematical statement. So 4x minus 2 is an example. Equivalent means we've been using the same. We've been saying that more formally. It's statements which are equal in value. They're equal in value. So for example, what does that mean? When you're studying this, you ask, what does this mean? It's like 3 plus 1 and 4. They're both equivalent because they're statements which are equal in value. This left side is 4, this right side is 4. Equivalent expressions are a combination of these two previous vocabulary words. So two expressions which are equal in value. They also have this other important property. Since they're equal in value, if you plug a value into each expression, you get out the same value. For example, what does that mean? Say we have 2x plus 3 plus 5x and 7x plus 3. As you guys notice, if you combine like terms there, you will indeed get equivalent expressions. But the second part of this definition, which is what we're referring to and which we studied on Friday, whereas if you plug in a number, any number, that's the cool part, any number, if you plug in, say, 1 into your expressions, you get out the same thing. On the left-hand side, 2 times 1 plus 3 plus 5 times 1 is 10. And then 7 times 1 plus 3 is also 10. All right, moving on. Substitute. Substitute means to replace. We like the words plug in. To replace a variable with a number. So if we have 5x plus 3, it would be 5, and the substitution would be us replacing a 5 with a 4, or any number, whatever the variable may be. Simplify means to, it's an action, it's another action. So substitute is an action, substitute is an action, and simplify is an action you do. So if you simplify something, you reduce the numbers and symbols in an expression while maintaining equality. We can't just combine things left and right for no reason. We have to make sure that what we're doing is valid. And you guys do that naturally. So if you simplify something like x minus 4 minus 3x, you should get negative 2x minus 4 when you combine like terms. And these two statements are maintaining equality. They are equivalent expressions. Okay. Evaluate. This is another verb. Evaluate means to compute the numerical value of an expression. To compute the numerical value of an expression. For example, this is kind of the PEMDAS. If you evaluate something, if you evaluate 3 plus 7 times 5, no, it's not 50 if you use order of operations. It is 3 plus 35, which is 38. That's the process of evaluating. Next up is the distributive property. This is not an action, this is a property. The next one, distribute, is an action that you do. So the distributive property is a math rule which states that A times B plus C equals the same thing as A times B plus A times C, where B and C are just numbers. Now this looks like confusing. Perhaps you're thinking that. So an example that you guys see is the distributive property, 4 times 2x minus 7. When you use the distributive property, it's 8x minus 28. That's the distributive property. I use these letters because it's more general, and that's pretty much algebra. Distribute is the process of using the distributive property. Pretty self-explanatory there. Again, same thing. 4 times 2x minus 7, and you're multiplying it out. 8x minus 28. Like terms are terms which have the same variable. So for example, 4x and 3x are like terms because they both have an x. Also, 7 and negative 8 are like terms because they both don't have an x. They're like terms. Combined like terms is the process of putting the terms together. The process of putting the terms together. So for example, 4x plus 1 plus 2x is the same thing as 6x plus 1, combining like terms. An equation is what we are just starting this brand new unit on. This is important. An equation is a statement with an equal sign. Some of these statements are true, some of these statements are false, some of these statements we aren't sure about, but all of these statements have an equal sign. 4 plus 2 equals 8. Hey, well, you may be laughing. That's not true. Well, yeah, that's not true, but it's still an equation. A statement with an equal sign. 5 minus 4 equals 1 is an equation that is also true. It's a true equation. And 2x plus 6 equals 23 is also an equation that we aren't sure if it's true depending on what x is. And that leads us to solution. The solution is that value of x which will make it true. Which will make it true. So a solution is the value which makes the equation true. So say we have x plus 4 equals 10. X equals 6 is the solution because it makes the statement true. And to solve an equation, that's what we're going to spend the whole unit on, is how do we solve equations? How do we find these solutions? How did I know that was 6? Because things are going to get more complicated. So how to solve an equation. So what does that vocabulary mean? It's the process we use to find the solution. You guys may have remembered last year stuff like two-step equations, one-step equations. 5x equals 25. You divide both sides by 5, which we'll learn about, and x equals 5. Alright, so those are your vocabulary words. Be sure to ask if you have any more questions or need to see some other ones. And I look forward to seeing you guys all on Wednesday.